Section 1.5 is on multiplication. Multiplication means repeated addition of the same number. So, for instance, if you have 3 times 5, which you know is equal to 15, if you wanted to, you could write that as an addition problem. 3 times 5 means that you have 3 5 times. And you're adding all those up. 3 plus 3 plus 3 plus 3 plus 3 equals 15. Because multiplication is commutative, in other words, 3 times 5 is equal to 15, which also means that 5 times 3 is equal to 15. You could also write this as the addition problem 5 plus 5 plus 5. Either way, you get 15 for an answer. Just remember the definition of multiplication. Multiplication means repeated addition of the same number. I mentioned the commutative property of multiplication. For instance, 3 times 5 is the same thing as 5 times 3 as far as the answer goes. So, if you have two numbers and you're multiplying them, it doesn't matter which number comes first. There is also an associative property of multiplication, just like there's an associative property of addition that we talked about in an earlier section. The associative property of multiplication says that if you have more than two numbers that you're multiplying, for instance, let's say 2 times 3 times 4, it doesn't matter which numbers you group together first. I could say 2 times 3 times 4, I'm going to first of all multiply 2 times 3 and get 6, and then 6 times 4 gives me 24. Or if I wanted to, if I have 2 times 3 times 4, I could multiply the 3 times the 4 together first and get 12, so then I would have 2 times 12, and 2 times 12 also gives me 24. So the associative property of multiplication is also a property that you might use. Perhaps the most important property when dealing with multiplication is the distributive property of multiplication. And you may or may not know, but you use the distributive property of multiplication all the time. Let me give you an example. Let's say that you wanted to multiply 7 times 83. Well, you could go through and do the regular algorithm that perhaps you have learned before, 83 times 7, and set it up the way that I just set that up and go through and do the multiplication. But the other way to do that is to realize that you are really distributing that 7. You are multiplying that 7 times the 8. But that 8 isn't equal to 8, that 8 is equal to 80, because the 8 is in tens place. So 7 times 83 is the same thing as 7 times 80, plus, then I would distribute the 7 with the 3, 7 times 3. Now I could go through and I could multiply those together. 7 times 80 gives me 560. 7 times 3 gives me 21. I add those together and I get a final answer of 581. I'll be talking a lot more about the distributive property of multiplication, but it is a property that we use a lot in real life. Not only do you need to know your math facts in this particular course and in all subsequent math courses, you also need to be able to multiply quickly with powers of 10. Let me give you an example. We had just done the problem 7 times 80. And I told you, well, 7 times 80 was equal to 560. I knew that because of the power of 0, as I call it, the power of 10. I know that 7 times 8 is equal to 56. And since there's one 0, I'm going to put that 0 at the very end, and I'm going to get 560 for an answer. Let's continue to do some other problems like that. If I had 70 times 80, well, I'm going to multiply 7 times 8. 7 times 8 once again gives me 56, but now I have two zeros in the problem. 2 zeros in the problem means that I need 2 zeros in my answer. So that answer is 5,600. If I was given something like 300 times 9,000, I'm going to first of all multiply the two numbers, the two single-digit numbers, 3 times 9. I'm going to get 27, and then I'm going to count how many zeros I have altogether. I have 1, 2, 3, 4, 5 zeros in the problem, which means that I need 5 zeros in the answer. I put that comma in the wrong spot there, and I get 2,700,000 for an answer. It's very important that you're able to multiply quickly with powers of 10. You will be doing that a lot when you are going through and estimating with multiplication. Let's take this one more step. Let's say that you had 32 times 10. Now, I don't have a single digit number here. I have 32, but it works exactly the same way. I can go 32 times 1, which gives me 32. I have 1 0 in the problem, which means I'm going to have 1 0 in the answer. If I had 32 times 100, it would be exactly the same thing. 32 times 1 is equal to 32, but now I have 2 zeros, so it'd be 3,200. So let's just review straight multiplication. Let's say that you wanted to multiply 492 times 7. You could just use the regular algorithm that I'm sure you have done in school before. I'm going to multiply 492 times 7, and the very first thing I'm going to do is I am going to multiply the 2 times the 7. 2 times 7 gives me 14, and you were probably taught you could put down the 4 and you're going to regroup the 1. Then 9 times 7 is 63, plus that 1 is 64. Put down the 4 and regroup the 6. 4 times 7 gives me 28. 28 plus 6 gives me 34. So I get a final answer of 3,444. And that is one way that you can go through and you can do that problem. I want to talk with you about another way of doing that problem. 492 times 7. The other thing you can do is, rather than regrouping, you can just go through and do the straight multiplication. 2 times 7 gives me 14. I'm just going to write down 14. The 9 times 7, I'm thinking about that 9 as 90. So 90 times 7, 9 times 7 is 63. And I'm going to add the 0, I'm going to get 630. The 4 times 7, that 4 stands for 400. So it's going to be 400 times 7. 4 times 7 is 28, and I'm going to need 2 zeros. So I'm going to have 2,800. If I add all those numbers together, I get exactly the same thing, 3,444. There is one other way that really is the same thing that I just got done showing you, but it's called the box method. If I wanted to multiply 492 times 7, the other thing I can do is I can set up a box. And I am multiplying 7 times 492. I'm going to put a 7 over here to the left-hand side, and because 492 has 3 different numbers in it, I'm going to break up that 492 as 40 plus 90 plus 2. And now I can just go through and I can multiply those numbers. 400 times 7 is that 2,800. Notice it's exactly what I have down in this second method. 90 times 7 is 630. Which I have right here in that second part, 630. 2 times 7 gives me 14, which is the first thing I had, and then I would add all 3 of those numbers up again, and once again I would get 3,444. In this class, I don't care what method you choose to go through and when you do multiplication. It won't matter at all to me. What will matter, obviously, is that you get the correct answer and that you have understanding for how you got that correct answer. It's when multiplying a multi-digit number by a multi-digit number that many people prefer the box method that I just talked about. But you can also do this problem, 56 times 47, the regular algorithm way. So let me just kind of go through and do that quickly again. First thing I'm going to do is I am going to pretend that the 4 is not there, and I'm just going to multiply 56 times 7. So I'm going to go 6 times 7, which is 42. Put down my 2, regroup my 4. 5 times 7 is 35, plus 4 gives me 39. So 56 times 7 is equal to 392. Now I need to multiply that 56 times the 4. But remember, that 4 is really 40 because that 4 is in tens place. Whenever I multiply something by 10, I know I'm going to have a 0 at the end. So I start off by putting my 0 there. And now I'm going to multiply. 6 times 4 gives me 24. Put down the 4. I'm going to regroup the 2. 5 times 4 gives me 20, plus 2 gives me 22. And then I'm going to go through and I'm going to add. When I add, I get 2,632 for my final answer. You might choose to do this problem with the box method. In doing the box method, because I have a 2-digit by a 2-digit, I am going to break up both of these sides into 2. That 56 I can write as 50 plus 6. The 47 I can write as 40 plus 7. And now all I'm going to do is I'm going to multiply all the numbers that are on the outside with the corresponding number and figure out my answer. When I go through and do this, the very first box here is going to be whatever that 40 times 50 is. Well, 40 times 50, 4 times 5 is 20. I have 2 zeros, so that's equal to 2,000. For the upper right-hand box, it's going to be 40 times 6. 4 times 6 gives me 24. I'm going to add 1 0. For the bottom left-hand box, it's going to be 50 times 7. 5 times 7 is 35, and add a 0. And for the bottom right-hand box, it's just going to be 7 times 6, which gives me 42. Now, when I go through and do that, I can go through and I can add these up. And you can just add up all 4 numbers. I oftentimes have a lot of people that add up this way. They say, well, 2,000 plus 240 is 2,240, which you can kind of do in your head. That 350 plus 42 I'm going to add up next. I'm going to get 392. Notice that these are the same 2 numbers, 2240 and 392, that I had when I did the traditional algorithm method. I'm going to add them up. I would get, once again, the exact same answer, 2,632. In the previous section, 1.4, we talked about estimation. And in this section with multiplication, once again, you do need to be able to go through and estimate answers. So let's say that we had 436 times 389. Once again, normally when estimating, we're rounding off to the highest place value. So in both of these cases, I'm going to round off to the nearest 100. So if I have 436, I'm going to round that off to the nearest 100. I'm going to underline the 4, put an x over the 3. Since that's a 3, the 4 stays the same. So 436 to the nearest 100 is 400. 389 to the nearest 100, I'm going to underline the 3, put an x over the 8. Since that's an 8, the 3 changes to a 4, so I also get 400. So now I want to know, well, what's 400 times 400? Well, that power of 10, power of 0 rule that I talked about works very easily. I know that 4 times 4 is equal to 16. I have 4 zeros in my problem, which means I need 4 zeros in my answer. So I'm going to put down my 4 zeros, and the estimated product of 436 and 389 is 160,000. Let me go through and do one more example like this. Let's say I want to know the estimated product of 275 times 52. That 275 goes out to hundreds place, so I'm going to round that one off to the nearest hundred. 275 to the nearest hundred is equal to 300. 52 goes out to the tens place, so I'm going to round that one to the nearest 10. 52 to the nearest 10 is equal to 50. Now I'm going to multiply those together. The 3 times 5 gives me 15. I have 3 zeros, 1, 2, 3, so I need 3 zeros in my answer. The final estimated product of 275 and 52 is 15,000. I mentioned at one point in this video how important it is that you have your multiplication facts memorized. For many students, not knowing the facts is what causes problems when doing multiplication. If math facts are a source of discomfort for you, I encourage you to get a set of flashcards or find a computer game that will help you in their memorization. As always, if there is something I can help you with in the understanding of the concepts in this section, please ask.